Hello, everyone, and welcome back once again to another episode of the Trino Community Broadcast. Feels like we've been doing this a lot lately. My name is Cole Bowden. I'm joined by Manfred. Manfred, it's been only a couple weeks.
Yeah, we're trying to amp up the speed of this thing, right? And we're doing like every 2 to 3 weeks. And on the website, we already have upcoming 2 further episodes organized. But let's not talk about that. Let's talk about what we're going to do today.
Yeah, so today we have a conversation with two wonderful people from VAST, a data platform and system that integrates brilliantly with Trino that we're really looking forward to exploring, understanding, explaining, asking questions, making them answer why we think it's designed certain ways. We're going to grill them. It's going to be really difficult for them. I'm just messing around, of course. It's always a friendly conversation on the Trino Community Broadcast.
Are you sure?
We'll have to see, Manfred. But before we do that, as always, we have to introduce ourselves. So my name is Cole Bowden. I'm a developer advocate here at Starburst. Manfred, you have a new shiny title here.
I just do the same thing with a different title. What are titles?
Director of Trino Community Leadership. And of course, we'll be joined by Colleen Tarto and Roman Zeta from Vast Data in just a little bit. But we have one release to talk about, 440 also coming soon. So stay tuned for that. But 439, we briefly hinted at it at the end of last episode, and it's here now. We have a caching layer for Delta Lake, Hive, and Iceberg.
Well, we sort of like cleaned house by throwing the old caching layer out, really. So we had one called Rubik's, and we threw it out and replaced it with an Alaxio-based implementation. So we kind of did a cache refresh, and I'm working on a blog post for that. So
yeah,
stay tuned on that. But it's there. Works for Delta Lake, Hive, and Iceberg connector, so it's much better than was there before, and it also has no security issues on that kind of stuff, which we had before.
Yeah, and it's more performant than the Rubik's one was, and that one was only for Hive. So if you're on Delta Lake or Iceberg, this is new for you. If you're on Hive, it's just vastly improved instead. No pun intended. There was many bug fixes actually in 439. I picked a couple big ones that seem like they may be generally applicable. You can now have periods in catalog names, which is
I'm like, why would you want to do that?
In case you want to confuse yourself, what if ... like 7 different dots in your name.
The next thing will be that people want to have emojis in their like name and like.
I actually love that idea, Manfred.
Oh, God, you're terrible.
The next database I have to create, the columns will be named with emojis.
Yeah. Another shout out I have to make for 439 release. So there is now documentation, what we've been talking about for a long time. Trino has native file system integrations. And when I talk file system, that means connecting to remote object storage file systems on S3 or Azure and stuff. So we have a new, much faster, better implementation. And the documentation is not there. So you have to actively switch it on. Please do that. Please let us know how that goes. It should be much better and faster and more stable than the existing one. And over time, we'll also throw the existing one away, but that's a long time away. But please start trying that stuff and let us know how it goes.
Yeah, and then finally, Manfred, Trino Gateway 6 was released.
Yay! We got it out again. Despite playing around with Docker and fighting that, we did manage to get a Docker container shipped for Trino Gateway 6 now as well. And that's the major change. A lot of other things that happened are like internal refactors. But there are a whole bunch of new features also lined up for Gateway 7, which is coming around the corner. Maybe by the next episode, I can tell you about 7.
Yeah, so if you've been looking at the Trino Gateway and you're thinking, well, what if we have multiple clusters, or I want an FTE cluster in addition to my normal ad hoc one, easier than ever to get that up and running. Keep an eye on the Trino Gateway for more cool features to support that. But it's only been a little bit since our last episode, so not a ton of other things to report on, which means we can pull these notes out of the way and get our guests onto the screen. Welcome, Roman and Colleen.
Hello. Hi.
So could you two please just introduce yourselves? Let the world and the Trino community know who you are. Colleen may be a slightly familiar face to some, and Roman also. So
yeah, Colleen Tarto. I'm field CTO and head of strategy at Vast Data, and been using Trino for about, I think I first heard of Presto SQL in 2018. And that was sort of my first exposure to it. And then I did a lot of things with it, including running enterprise engineering at Starburst for a while, and I've been at VAST since the summer. I started, I think, in August, and yeah, I've been working with Roman since then, and it's been great.
What about you, Roman?
So Roman Zayde, I'm working as a software engineer here in the Vasta-based team, and this is our internal name, but yeah, and we're working. I have been working with Trino also from 2018. First as my previous job in Varada, the startup that was acquired by Starburst, and then switched to Vast Data, building our database platform from grounds up.
And like looking out the window on your end, it looks kind of dark out there. What's going on? Where are you?
Yeah, so I'm in Israel, in Haifa. It's in the northern part of Israel, and it's GMT +2. So it's 9:30 p.m. here.
So you're heading to bed after this. Well, we have to keep working. Oh,
no problem. No problem.
Do we? I mean, you know.
You can get a lunch break in there for us still. So thank you, Roman, for being able to make time in your evening to come on the Trino Community Broadcast. We appreciate that a lot.
My pleasure.
So first question. You just said faster base, but isn't it also a faster database? So it's like a faster data, whatever pasta base.
Let's throw that back a little bit, Manfred.
Yeah,
what is that? For
is
those who are unfamiliar, Colleen, I'm going to pose this to you.
Okay.
Give us the 10,000-foot overview of what is VAST and why do we care about it?
So the official name is the VAST database, is the piece of the VAST data platform that we're talking about. But we do call it the VAST database just because it rolls off the tongue so nicely. So VAST began, I think, about 6 years ago. I think it came out of stealth like 3 or 4 years ago. But the idea behind VAST is very similar to the idea behind Trino, is that the entire data ecosystem was built around like legacy stuff, right? Legacy hardware, disk drives, systems built to work around the challenges of the hardware of the time, spinning disks. And so turns out it's the 2020s. That's not the world we live in now. So VAST was started with a focus on all-flash storage. It's a really cool design where we use storage class memory and QLC in a really intelligent way to maximize your cost efficiency, your performance, scalability of this all-flash data lake. And so with that, we can store pretty much anything, and it's a multi-protocol environment, meaning it's easily accessible for whatever our customers are doing. And that really makes for like this best-in-class high-performance computing AI. You know, you can do whatever you want today, but then also it's scalable and it'll work for whatever the next big exciting thing post AI is, whatever that is. So in more detail, you know, our platform has a few different angles that make it special. We've got the VAST data store, which is sort of like the base layer, the data lake for all of the data, whether it's structured or unstructured or semi-structured.
So,
and then we have,
when you talk about lake, sorry, I want to have this chat about this. So a lake typically always talks about object storage, but you talked about flash now. So is it like both or like?
So it's an all-flash storage system. And so it's software, but we also partner with we have hardware partners that ship like physical servers on racks that VAST is already installed on. And, you know, that's where my brain starts to tune out, is when people start talking about like racks and cables and things. I'm like, that's nice. Get back to me when we're talking about data.
Yeah, but you know, there is this whole trend about getting out of the cloud and saving money and having your own hardware. So this is like a way into that,
and
right?
people call it repatriation, which I find hilarious because it's like, you know,
yeah, like your data, like your data center is like in your office in the basement, right? Like,
but I mean, the scales that we're talking about, you know, putting everything in the cloud is really expensive at that scale, and so a lot of times it does make more sense, especially with the growth of data and what people are doing with AI, to start thinking about, well, maybe a data center makes more sense, right? Or maybe they're partly in the cloud and partly in a data center, and they want to bring things back in the data center. And so we're seeing a lot of that with our customers. But yeah, so our VAST data store is the base storage, which is where you would just put all of your data. And then we have, for structured data, we have the VAST data base, which is like a table format based on our internal element store. And it's got some other interesting bits and bobs and accelerators in there. And then coming out later this year, we've got the VAST data engine, which is a Kafka-based engine that Roman is probably sleeping and dreaming about. That's going to add triggers and functions to the pipelines and really round out the way the full data platform image works for us. And that's sort of our image, our vision that we're going for.
So you said two different things here. You said engine, and then you talk Kafka. But when I think about database, there's always like a query engine in play. And when I talk about querying a database, how do you query VAST database?
Is there perhaps a bunny-themed query engine?
If only there was some sort of lupine themed. No, is lupine wolf or bunny? I forget.
Lupine is wolves, but like we have lots of bunnies, so the wolves run away.
If there was only some
I'm Googling
rabbit
this right now. I need to know.
Yeah, some really cute Ali Loney designed rabbit themed engine that we could use. So basically, the VAST data engine is sort of a larger Kafka designed engine that'll be like, a data set comes in and it gets triggered to be moved somewhere, or a function runs on it, that kind of thing. Whereas the query engine that you could use something like Spark, you could use something else, but you really probably should be using Trino, right? So, so that's sort of where Trino comes in, because let me just plug the database and give you like the high level of why our database is awesome. I think it's really cool, and so the way it works, it's functioning as both an OLTP or a transactional database and an OLAP or analytical database. And so what happens is when data comes into it, it's written in rows in an ACID compliant way. And so it takes data into a write buffer and writes it into rows, but then it passes them down into columns, into a columnar format. So when you read the data, you're reading it in a columnar format. So you're getting the best of both worlds, the transactional and the analytical, which is really freaking awesome. And so, and it's optimized for the VAST storage format itself. So that underlying element store. And so you're getting like really insane ingest and query, like selective query performance. And so, Roman can tell you all the details about why that works so well, but it's just a really awesome product in a forward-thinking way that I appreciate. And so when you add Trino on top of that, you just get these like blazing fast queries, and it's like gives you back other time to do things in your life.
So you threw out the OLTP and OLAP kind of fancy words. So from a practical perspective, that does mean that as an application developer, you can hook up your application to do your order placement or whatever into VAST, and it gets there in a row level kind of like access kind of feature. But then the same database can be queried for your dashboards and sales reports, blah, 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 all the aggregation without you having to do anything.
That's exactly right. You haven't done anything. You didn't have to build a pipeline from a transactional database to an analytical data warehouse, right? Or a data lake. You didn't have to do anything. It just automatically, magically happens in the VAST data platform, which is really awesome.
Well,
that's cool.
While we're talking fancy words, leporine.
Thank you. I'm like, I knew it began with an L, leporine.
All right, you're going to have to look up Canis. I'm pretty sure Canis lupus is wolf or something like that.
Yeah. Lupine is wolf-like, but leporine is the word we were looking for. So it's,
we're
talking about the leporine connector for VAST today.
No Latin. No Latin.
What do you mean? You did physics, so Latin should be fine with you.
More Greek, actually, but yeah.
Yeah.
In any case, let's talk about that Trino connector. What's the process of architecting a normal query engine to connect to this sophisticated new age data system? How'd that happen?
Yeah, so actually, the great question. Unfortunately, I don't have a slide, but I can I can actually make a 2.5 week year rewind and replay our decision and the things how we try to design this. So, initially, the element store, as Colleen told before, was a framework software framework that actually underlies everything that VAST does. So every file, every object, everything that VAST stores and exposes to the user, to the end user, underlying it, there is a vast data structure that allows writing a lot of files, reading a lot of files, deduping a lot of files. So if you have similar files, the underlying engine knows how to find similar chunks of data and compress them together to make to make your Flash to make your use of Flash much more efficient. And in addition, since it's everything on Flash and everything can be accessed in parallel, it behaves like a very, very, very fast storage engine. So in addition, it allows very fast updates and very fast, not exactly in place, but very efficient modifications of data. For example, if you have a large file and you modify only a small part of it, you don't read the whole file and write it again as a new version of it, as you usually do for example, in S3, right? Because it's in a mutable block storage. So underlying the infrastructure that we were using allows us to do such tricks to allow, for example, analytical users that usually do operations like select and query and inserts, which are usually fine, but updates and deletes are usually very, very costly, because it's hard to delete a single row from Parquet file. Usually what you do, you just mark it as deleted, and once in a while you do some kind of a compaction, and then you throw the old Parquets away. And there's a lot of, I call it file ops, needed to make everything work in more or less a nice way. So because we have all this infrastructure already in place for managing files in petabyte scale, actually, the idea was, let's reuse it and build the basing blocks of the database from it. And then when we have them, we can start building everything, just a layer after layer. But when every layer is built, in a good and connect in a way that maximizes or minimizes impedance mismatch, because when you use S3 for storing data, mostly it is fine when you only read it, but when you need to modify it or delete stuff, it doesn't really work. And so what we did, we actually started, because my previous work in Varada, I was quite familiar with the connector model that Trino, actually, I think Trino was one of the pioneers of how to connect a query engine to various data sources, which is fantastic. I think other databases can learn a lot of from Trino, how to, first of all, how to make your query engine as connectable as possible to other things. And in addition, its documentation is great. we were developing other connectors and for other data query engines, and Trino rocks. So it was a it was a pleasure developing. So it was
I think a shout out goes to Jan for writing some of the developer guide there.
Yeah. Oh gosh.
Yeah. So what we did, we actually first analyzed what Trino can actually push down, provide us as the data storage engine to VAST, and then we started to define the basic interfaces. So, for example, the basic thing to start is, how do we define schemas? How do we define tables? How do we define columns? Which types are we going to support? And then the internal, the underlying storage that our team has. We have started with it and we're continuing it, and I think it was a good decision. We're using Arrow format, the open source the open source project of I think Apache Arrow.
Yeah.
Right? They have pretty much became, I think, de facto standard of data interchange and format interchange of data, and they have multiple projects that use this format to query, to process it, to do interesting stuff with it. And we are actually VAST. Our data engine uses Arrow to represent and to internally encode the types and the data in the Arrow compatible way. So it's very easy if your application speaks Arrow buffers, Arrow formats, Arrow vectors, Arrow data. You can very easily interact with VAST. I mean easily. I mean with very little impedance mismatch. So you just get buffers out of our protocol, or we kind of developed our protocol in order for you to insert data, get data, and manipulate it inside VAST, for example, delete data or update data. And all the buffers you send over the protocol are encoded in Arrow. So So I think we're not the only one. I think BigQuery, if I remember correctly, the BigQuery connector also uses this trick in order for
there's more systems doing that. However, like Trino doesn't use Arrow internally because it was around long before Arrow even came up. And so how does that work in terms of like the VAST database connector for Trino? What are the mechanics? Like you have Trino running, you create a catalog that uses the VAST connector, and then like how does that connector do its work? What is it doing?
Yeah, so actually in VAST we manage both the data and the metadata. So this is a nice thing. You don't need to configure, for example, Hive Metastore or some other Metastore service that, for example, Glue or something like that, that stores all the tables and the schemas and the columns. Everything is stored inside VAST, and our connector communicates with the VAST cluster via RPCs. So we define I would call it S3-like RPCs. So because VAST already supports the S3 commands, S3, I think it became a kind of a standard way of accessing.
So it is not a JDBC kind of connection. It's more like a lake connection, like I don't know, like the Iceberg connector. So that talks to the Iceberg format. It's more like that. But the Metastore is built in. Is that how this kind of work?
Yeah, you can think about it that like S3, most of the data lake connectors usually talk to S3, right? Using some kind of a RPC layer. I think they just send and receive send HTTP requests and get HTTP responses with the data encoded in some kind of way. So we just extended our the standard S3 protocol that VAST already supported with new commands. Yeah, and then you can just send a command that is called create a table, and it automatically created behind the scene. You don't need to talk with any special Metastore. You just create it on the way. You can send the command list table and get in a list of tables, and then you can use a table and just send a query for this specific table or insert to this specific table. It just works.
Yeah, awesome. So the connector is like other Trino connectors that support read and write operations. Then
yes. And
how far has that gone? Like, do you also support like the more exotic stuff, like creating schemas and like creating views, maybe, or materialized views? I'm going to ask all the hard questions here, right?
No problem. So we currently support schemas, tables, of course, columns. Most of the types we do support. Of course, Arrow doesn't cover all the various types that Trino currently supports, so maybe some adaptation will be needed. Currently, we indeed don't support views and materialized views, but we can add support later, I guess.
Okay. Cool.
We do support projections too, which is like a really cool performance enhancement.
Yeah. So
what is a projection in this context? Like how would you is that like how would you query a projection from Trino?
So I think the word projection, I think, is used in various contexts. So we decided, I think, to call it we actually the full name is semi-sorted projection.
Yeah.
So for example, if there is a column that is not sorted initially, usually so I will start by saying that because our system enables us to store metadata for every, I guess, quite small block of every column chunk, every, I think, 60
32K, isn't it?
Yeah, 32K kilobyte of values. It gets its own metadata entry with, for example, min-max statistics that you can use.
Okay, so that's awesome. So your connector also like provides the table stats to Trino, so then Trino can plan the queries, like basically cost optimized and like optimize the plan for it based on the statistics.
Mm-hmm.
Yeah.
Oh, that's cool. So if that's the case, then also I'm assuming, since it's more like an object storage connector, it also has the full parallelization. So if you have a cluster running of like, I don't know, like 100 nodes, it just hammers the VAST database on from those 100 nodes.
Exactly. And because VAST is a massively parallel system, it works really, really well.
Yeah. MPP on both sides, that gives you speed, right?
Indeed.
That's awesome. So where does VAST run typically? And then how do you get Trino hooked up to it? Like,
So usually VAST is a storage that used by in on-prem settings, right? And so users usually they have their own storage cluster, and then if they need to query, they usually spin up a Trino cluster near it. Usually it's very close, both physically and latency sense. So they get pretty much good performance. Actually, one of the things that I was very surprised to see is that how well the basic performance, even before we started working on our connector, the basic Hive and Iceberg work pretty well when you have where your initial latency is pretty small. So this is quite nice.
No, that's definitely one of the performance, kind of you want to get performance happening, you need to be close in terms of network, and that's like a bottleneck. Like it's always something that we see, people are like, oh, my queries are slow, and then they're like, oh, I have this very small cluster and my data is on the other side of the globe and the meta store is slow. I'm like, okay, so now why are you surprised it's slow again?
Yeah, definitely. I think we had some use cases that people had tables with, I think, thousands of columns, and querying them via Hive Metastore was a pain. And it just worked on our database without us doing anything special, because just when the building blocks are have good performance, everything just works above, which is cool. Yeah.
Well, don't tease our users, because there is people out there that have too many columns in tables. Like thousands is fine, but I literally ran into discussions where someone is like, I don't know, they have I don't know how many, but in the tens of thousands of columns. I'm like, that's more than Trino can manage from a memory point of view. Don't do that. I'm like, what data model did you think of that is smart on that aspect?
Yeah, I think we had one test that tested this specific use case, and I think it was mostly bottlenecked on some loop happening in a single thread in Java, and I guess
it's memory, right? It's kind of silly, but so having this all close together, and the VAST database being a storage system, but it's also a compute, you called it a VAST platform before, right? Can you tell us more about what that means? If there's compute in the system, can Trino use that compute, or how does that work? Or what's the common pattern on how your users are approaching Trino? And that's another question, by the way, I just thought of. How do how do they come to you and say, hey, we need to support, you need to support Trino because we want to use Trino, or are you telling them, or both, or tell me a bit from the field what's going on.
From the field, I mean, a lot of our customers, are already using Trino, right? We've got some pretty cool use cases out there where, I was at Big Data Paris and somebody came up to me, and I was, my broken French, I'm trying to have this conversation, but the one word we kept coming back to is Trino, right? Le Trino. But, it's one of those things where, they had Trino, they were doing it off of S3 and it just wasn't performing well, but they had unstructured data as well. So it was one of those things where VAST was a great use case for that. And Trino plus VAST is just performing so much faster, and they're very, very happy. So, we have a lot of different cases like that. I mean, Trino's everywhere, right? So we are seeing that. And then when we have customers who are open, they'll, we'll talk to them about what are they doing in the long run? Are they, focusing more on the AI stuff? Are they, looking for data science, BI? But, a lot of times we'll suggest Trino just because it's so much easier to spin up than anything else. The architecture of it is much simpler than Spark, for example. So, but that said, I think it depends what they're doing. And a lot of people most people do have an opinion by the time they come to us. So.
Okay, cool. So that then also means, to some degree, when they come to you and they already have Trino, that means that they have already some catalogs and data sources configured. Is that something that you find often, where people have I don't know, probably we mentioned S3, some sort of do you also end up with use cases where people have some legacy relational database, and then the data gets migrated over via Trino, or what are some of those things?
Yeah, I mean, Trino, we definitely have done one-time migrations with Trino from something else into the VAST database. That's pretty popular, or Parquet into the database. honestly, like our customers, like everyone, are trying to minimize their number of pipelines that they have, right? And so Trino is a key piece of that, as is VAST, right? And so like that's really the name of the game, is like minimizing the movement of data around. And so whether that means they're doing something as big as repatriating everything back into a data center, or if they're just trying to like minimize the number of pipelines and using Trino instead, then we can supply the backend for that from an S3 standpoint, or they could actually migrate into the VAST database, which they often do, because what happens is the query performance is so significantly better with VAST plus Trino versus Trino plus whatever else they're using, like Parquet on S3, that it's a significant hardware savings at the scales that our customers are talking about. And so like you can actually like rip racks out of the wall if you want, because you're between the compression and the query performance, like you're just really significantly reducing your compute footprint.
Yeah, I guess like also since you can hook up actual transactional systems and applications to it, that also saves that whole ETL, ELT, whatever you want to call it, moving around stuff. So that's really cool.
Yeah.
So tell me, how do these people like manage their Trino clusters? Like, do you help them with that, or do they just like know already? Do they use our Helm chart that we're kind of trying to maintain, or like?
I mean, it's a little bit of everything. Some folks have been using Trino for 10 years or whatever, and we don't need to help them. And then some folks are new to it and they have some questions and we can help them. I think it's sort of a mix at this point. I don't know, Roman, do you want to talk about the C node structure and how that works, or we could get into the details if you want.
About the C nodes?
Sorry, C nodes.
Yeah. Actually, this also can answer your question, Manfred, about
Awesome.
the compute that we're actually helping to offload from Trino. So because our platform is, of course, developed by VAST, we have good, and the guys that write the code is actually sitting around here. So one of the cool idea that we wanted to use Trino for is to push down as much as possible things that can be done inside our C nodes. C nodes are shorthand for compute nodes. The containers that are running VAST logic over the whole flash and all flash drives. So our connector, Trino connector, is running inside Trino, and during the planning, it tries to push down and understand as much of the predicates that Trino pushes down.
Okay, cool.
And we actually did, when we started the project, we took a look at everything that can be pushed down from the Trino's point of view, and we actually started, we opened a lot of tasks inside the C++ code in order to support everything that Trino can push down. So initially it was just a copy paste of everything that can push down, actually supported by VAST. But then you guys added more and more push down, which is cool. So thank you guys. And
it's a moving target. We always want to add more.
Yeah.
Sounds great. For example, you added I think a complex expression, a push down, and we thank you very much. We used it in order to push like expressions, for example, in order to have them run inside our CPP engine, which usually can make better use of the CPU resources and get less data to the JVM, which probably better, and in addition, because we have indices, min-max filters and other ways to index data, we can actually move less data from disks using this metadata, using these optimizations. For example, one trick that we did, we saw that one of our customers is usually like to not to filter, for example, by some basic predicates. For example, instead of running a query like select x where y equals 2, they usually just run a query x equals 2. Select x equals 2 from table. So okay, nice query. But what happens if x is a string and the thing you want to get is x is null? Okay, so what usually happens? You don't want the actual data of the string. the only thing you want is the bitmap, the validity bitmap. So before we implemented that, we actually understood that, wow, we're reading a lot of data of the string data.
Just to throw it all away. Yeah.
Yeah. Well, all what we needed is only the bit, a single bit for every row, that whether it's null or not null. And we actually implemented this pushdown. We call it projection pushdown. And I think this is supported by basic Trino primitive. We just had to think about it. And then when we implemented it, all those queries that initially were moving a lot of data for nothing just got much faster. So thank you, guys.
That's cool. So there's a bit of like processing basically going on in your like system and engine as well. So so you're obviously managing this Trino connector. How are you doing that? Like, what Trino version are you supporting, or like, are you managing a fork, or like how you're dealing with all that? Because obviously our SBI, sort of the interface that you have to implement, changes from release to release, and you need to sort of keep up. And obviously you want to keep up because new projection push, all these new features coming in. So how are you managing that? I'm sure it's like fun.
Yeah, it's always, as you said, it's a moving target. So when we started the project, we started with it was quite a while ago. We started with the Trino 375 because it had this nice projection, complex expression pushdown, and really wanted to use that. So we started with 375, and then we implemented various features that we wanted from Trino. But then I think when you implemented the merge support, we took a new version that got that, and we just the usual software engineering work. We had to move to use the open source version, the latest Trino open source version, and to make sure our connector, which is developed out of Trino, we compile it based on the open source Trino to make sure everything works. We found a few issues here and there, but mostly it works.
Yeah. So our plan though is to always update. So we release quarterly, and we actually we're partnering with Starburst, and so our plan is to always tie ourselves to the Starburst LTSs as best as we can.
Yeah.
Okay, that's cool.
I know a thing or two about the Starburst LTS process.
Oh, really? I wonder why.
As you might imagine.
Yeah, no, that's cool. So you're like basically maintaining that and like that. So. Yep. But you're maintaining it internally. So how do people go about wanting to try this out? Like, is there like a trial thing, or is it open source and they can just like play around with it, or do they need to buy a whole data center? Like, tell me more.
Yeah, you definitely need to buy an entire data center. Buy your own
cloud.
I
thought, dang, I can't get to try it today then, I guess.
I take cash.
Yeah, so I think, you're right, guys. So in order to test our connector, I think the most expensive thing is you need actually actual hardware to run VAST software on. But then you can actually, our connector is part of our GitHub repository. So everyone that wants to use it can just read the code. It can compile it themselves. So it should work even without our intervention. We, of course, distribute the binary release of the connector, so you can just download it from our GitHub releases, and if it works for you, and your VAST cluster, we'll be more than happy to hear.
Yeah. So current customers, a lot of them have just downloaded it and play with it without us even knowing about it. And then we have like an extensive POC program. So because obviously like we don't want to have like a huge lift of standing up a data center in order to try VAST. So like we have like an internal POC program and things like that people take advantage of a lot. So
you can also potentially like try it on some cloud provider, provided you get the right images.
Yeah. So if you go to the AWS marketplace, you can go to AWS or GCP marketplace and spin up a VAST instance in the cloud. VOC, VAST on cloud.
Okay, so there is instances around that have the necessary like storage attached and that kind of jazz.
Yep.
That's cool.
Cool. Yeah, it's fun.
Mm-hmm.
Yeah, it looks very interesting to like play around with such a faster base.
Faster base.
The faster base.
Fast and
that's very cool. So what's coming in the future from you? Like, what's the plan next? Like, with?
So obviously, like, looking at the roadmap, like the engine is dominating the roadmap right now. I'm sure that's what Roman is working on right now. But we've got a lot more features. We're all about performance and just making queries more resilient, ripping out pipelines from our customers, that kind of thing. So anything that can help us do that is where we're focusing. But so query acceleration, we've got other connectors that we build, et cetera, et cetera. But yeah, well, we're pretty excited about.
What do you mean other connectors you build, et cetera, et cetera, et cetera? We want to have them in the Trino community. Tell me more.
I don't know how much work we're doing on Trino other than like updating it to the latest Trino. Like, Roman, do you have any idea about that?
Yeah, I think there are new SPI additions that we would be happy also to experiment with. Also, more optimization that we can do. I guess initially when we started the project, Trino, of course, as you described, is and still using a non-arrow internal format to represent the data. So we did some conversion between the two. I guess there probably a place for optimization in that sense. Because some of the types are quite similar between arrow and Trino page format, but unfortunately some others can be optimized. Some other types need manual conversion, so we can probably maybe try to optimize also those. We also would be happy to use more advanced Trino features to help the users with other tasks, for example, for importing data. When you try to get that data from Parquet files inside our system, it usually not very fun task, but usually people need to do it because they're initial or they start with some huge data lake in Parquet files, and they need to move all the Parquet files inside Vastabase, or they just they ingest their data. They just once in a few minutes they get a new Parquet file and they need to push it inside. So one of the nice things when you own the whole data lake, you can just do the moving of the data. If you because we expose an S3 compliant view of the system, you can just put a small file inside this S3 bucket, and then you can execute a small command in SQL-like language. No problem. And then from Trino, you can execute a small command that actually takes this small file and internally inside VAST, inside CPP code, just ingests it right inside the our internal data store without moving it into the JVM and back into the connector. So instead of doing a expensive insert into table as select or create table as select, we just issue a new, we kind of invented a new kind of command that allows us to do internal imports without moving any of the heavy lifting into the JVM. The cool thing in Trino is that Trino supports transaction. It supports it pretty well. And we're actually using that to make these imports atomic. Because we can start a transaction, we can import a lot of, we can do the imports using the same transaction, and our vast storage engine uses those exactly Trino transactions to make sure everything happens atomically. So if anything goes wrong, you can just roll back everything and just nothing happened. And this is a really cool thing because you can now import stuff, and you can just, when the import is finished, you can commit, and you can be sure that everything you want to import is imported. And most of the data is not even moving through the JVM. Most of the data is moving from S3 from one. Actually, it's more like I'm moving data from one pocket of VAST to another pocket of VAST without it even moving into the JVM.
Oh, cool. Since you mentioned the importing and stuff like that, I'm guessing your connector also supports most of the different data types, right? Like in Trino, like the standard ones, and then and then often I guess there's use cases where like external data comes in via CSV or whatever, or JSON file. You can sort of on the fly convert them then into your format, right? So make that more performant there as well.
Yeah, so we have our import supports natively the Parquet format, which is quite popular these days. And if we have other, for example, CSV or JSONs, we usually suggest using just Trino in order to do the path via the JVM, because just you can do anything that you can imagine, I guess, just using SQL and Trino, which, again, thank you guys for all the features.
Well, we'll look forward to see and hear from your bug reports on problems you find and the pull request to fix them.
We have some PRs out there.
Yeah,
and if you, I should plug, we have a couple of blogs on our site. If you just go to vastdata.com/blog, there's a few blogs that have like demos within them on, using Trino to query the VAST catalog, which is our metadata index of all of the files on your VAST system. And then we also have one with Trino query performance on VAST.
Awesome, cool. So people can find you on, what was again, vastdata.com?
Yeah.
And where can they find you? Is there like a VAST Slack or like just a contact us form or something like that, I guess?
I'm sure there's a contact us form where you can find me and Roman on LinkedIn or the Trino Slack.
Oh, yeah, that's right.
Always on the Trino Slack.
We're all on the Trino Slack. That's good to know, right? So feel free to find them there for any further questions. Thank you so much. This is awesome. Anything else you want to tell us about VAST before we round out this show today?
I don't think so. This has been fun.
Yes, unfortunately, we lost Cole. He disappeared off the face of this earth or whatever, something.
Cool.
His device is not connected. I'm sure he's fine. Maybe one of his cats tripped a cable or something. But I'm sure we'll see him again next time. And with that, thank you so much for joining me. I'm going to talk about a few other things next. Sounds good?
Thanks for having us, Manfred.
All right, cool. Thank you.
Bye.
Yeah, so that was, again, Roman and Colleen from VAST Data. Super interesting use cases they have for their combined very fast and vast database. So check them out. Couple other things housekeeping-wise. Can you believe it? Trino Fest is coming to Boston. The announcement is out, and I'll need you all to register now. Go to the Trino website, trino.io. Check out the blog post there about Trino Fest coming in Boston. We'll be there in person, and of course, you can also join us virtually and attend live from wherever you are on this globe. It's going to be on the 13th of June at the Hyatt Regency in downtown Boston. So make sure you book your flight and organize your hotel and stuff like that. We have a hotel block there at the Hyatt Regency as well. And for those of you that are contributing to Trino on the next day, which is Friday, the 14th of June, we'll also have a Trino contributor congregation. So if you're interested in that, join us and talk about, like, with the maintainers and contributors about, deeply technical issues and discussions on that. Please reach out to me or Cole. So, and obviously also tell all your friends to come to Trino Fest, because you never know. Commander Banban might even show up in, I don't know. Currently, it looks like he's training for a marathon for the Olympics or something like that. He might be ready by then, hopefully. I know I should probably be training a little bit as well, and maybe I'll be able to run a little bit. But all that said, so Trino Fest is coming to town. Make sure you attend. Also, upcoming other events, please check the Trino website. You will find the Trino events calendar there. And also on the broadcast session, we will have another Trino community broadcast in 3 weeks where we'll talk with with David Phillips and Matt Stevenson, who implemented open telemetry support in Trino, which is super cool for observability across the whole Trino stack, incoming, understanding what's going on when your queries are like having problems over the whole cluster. I'm sure they'll have a cool demo as well, and it's in the documentation how it works, but like talking to the developers is always more fun and super cool. So join us for that as well. And then a little bit later, we'll have another episode with Mitsu, where we'll talk about their client tool that allows you to query Trino with a no-code approach, right? For those of us that know how to write SQL, but not exactly like keen on that, and maybe sometimes it's more fun to just click a few buttons and get a nice dashboard report. Mitsu is great for that, and we'll find out more details about that. So join us for that as well, and I will see you in one of those next episodes. Again, thank you for Roman and Colleen to join us, and I think that is it for today. Let me just check again. Yeah, that's pretty much it. So make sure you book for Trino Fest, register to attend, and submit your speaker proposals. I'm looking forward to see lots of interesting sessions. I know there's cool usages out there. We heard from VAST today, and there's many more. And with that, I will see you next time, again with Cole as well.